Hi everyone. In this video we're going to look at reactions of acids and bases. And so we'll be able to predict the products of an acid-base reaction and label those as conjugate acid, conjugate base, and see the relationship between those and the reactants. Okay? So I have a pretty straightforward example to show you off the bat here. So we have HCl and water. So we're familiar with hydrochloric acid as functioning as the acid. And if this is the acid, then this has to be the base. And in order to be a base, it must have lone pairs. So we just want to confirm that there are, in fact, lone pairs here. And then if these were going to react, the acid, as a proton donor, is going to give up the proton. So we would produce Cl, which has gained a pair of electrons, and it will have a net negative charge. And then the base will accept the proton. It will become H3O, and then a formal positive charge there if we account for that, okay, which you should. And so now we can, place some kind of arrow here. And the arrow here, I'm just going to put an equilibrium arrow. We'll talk more about the specific kind of arrow that you want to put here in a later video. But we have an acid that produces some base now here, right? It no longer has protons. It can't function as an acid. So this is called the conjugate base. And then the base produces an acid, which is known as the conjugate acid. So the conjugate acid, conjugate base pair, and then we have the acid base pair on this side. So the acid is related to the conjugate base, and the base is related to the conjugate acid. So those are some relationships that you want to keep straight in your mind for yourself, okay? These acids lose a proton to produce the conjugate base. Bases gain a proton to produce the conjugate acid, okay? Acids lose, bases gain. All right, now let's look at an example, something like ammonia and water. All right, so I'm going to tell you that ammonia is going to function as the base here. And in the next video, you'll be able to understand why that will function as the base. So this must function as the acid. Okay. The base is going to gain a proton. So it would become NH4+. And the acid is going to lose a proton, OH. It gains a pair of electrons, so that'll become OH-, right? We had 2 lone pairs here to start, and now we have 3. And we can place our arrow here. Again, we'll learn more details about this arrow. And just because I've done this on paper doesn't mean that in practice, in the lab, it would go forward to produce products. We're just predicting what the products would be. Okay, it doesn't mean it's going to be a product-favored reaction necessarily. We'll have to look at what we would use to predict that, and that would be pKa values, which we'll talk more about that in another video as well. Okay, so the base produces the conjugate acid. I'll just abbreviate it. And the acid produces the conjugate base. Okay, so again, the base is related to the conjugate acid by the addition of a proton, and the acid is related to the conjugate base by the loss of a proton. Another aspect we can look at with respect to these reactions is a mechanism. So in organic chemistry, organic chemists try to predict what is happening at the molecular level, right? How are the electrons moving and atoms changing places? So we use what we call curved arrows to indicate how electrons move in a chemical reaction. And in fact, we show the arrows moving the electrons, not atoms. So your arrow, something like this, must always start at an electron pair, right? You cannot start it anywhere else. It can start as an electron pair, or it could start with other kinds of electrons, such as electrons in a pi bond, but something like this. It can never start at an atom, right? We would never do something like this, and we would never do something like this either and take the hydrogen and move it towards some atom B, Okay, so this is not allowed, this is not allowed. Let's put some atom here. So we have an atom losing or a donating electron pair, and here we have a pi bond donating electron pair. These are two examples of how to use curved arrows. You already saw curved arrows in resonance, right? When we were drawing resonance structures, we would draw curved arrows to show how we moved the electrons to get from one contributor to another. Here we're kind of doing the same thing. We're showing how electrons move in the reactants to give the products. Okay, so we know from our experiments that these are the products that we get from this chemical reaction. So how do we show that on paper? What would happen in solution? So the hydrogen from HCl is ending up on the oxygen here. So that means that this pair is going to reach out and grab this hydrogen, right? The electrons is where all the chemistry happens. So the electrons are going to grab a hold of that proton. Now, hydrogen, right, can't have more than a duet of electrons, 2 electrons in its valence shell. So since it already sees 2 with its bond with chlorine, that's got to give, right? This bond has to break. And so these electrons are going to be left behind on that chlorine atom. And that agrees with what we get as the product. So we're using our experimental results to make a prediction using our mechanistic theory to figure out what could be happening on the molecular level. And let me just tell you this, I'll say it over and over, this is the best guess as to what we think is going on, and it fits with our experiments. So for now, until some new results come along, this is going to work. Okay, so electron pair, grabbing the hydrogen, the HCl bond breaking to leave a lone pair. So if we connect the dots here, O is getting the H, okay, it has 3 H's now, and Cl is getting a lone pair, okay, it has an extra lone pair. We're good. My mechanism agrees with my experimental results. Let's do the same for the ammonia reaction that we looked at. So we have our base, and we have our acid. Okay, so if my acid loses the proton and nitrogen gains, then we have to show the pair on nitrogen here grabbing the proton from water. Of course, hydrogen can't have more than one bond, so the existing bond will break, meaning O will gain a pair of electrons, which it has. And so we just want to confirm, okay, nitrogen gets a proton, it does. Oxygen gets a lone pair, it does. This would be a sufficient mechanism for showing how these products are formed. So if you guys have a question about this, feel free to send me an email, shout out on Piazza, whatever's easier for you. And thanks for watching.